Okay, now we're gonna start changing the VS according to what we are here to get VD equal to zero point 0.1, then equal to zero point 0.2, then VD equal to zero point 0.3, and so on until we get to 0.6. Then after that we start recording VD when we go with the increment of 0.01. The increment here was 0.1. Then after 0.6, because we're getting closer to the forward voltage, we want to see exactly what's going on. So the increment will be 0.01. Okay, so if I want to change, okay, this one. Okay, so obviously I want VD to be 0.1, right? And here, this is pretty much 100 millivolt, which is 0.1 volt, right? It's very close. We don't need to get exactly the number of 0.1 because this is very hard and these equipment's not accurate 100%. So we're gonna pretend we are seeing 0.1 volt. Okay, so 0.1 VS, 0.1 volt on VS, give me 0.1 volt on the VD, and this is expected, right? Because we said before the forward voltage, the diode acts as an open circuit, right? So start recording and start filling your table here. So, okay. Okay, let me start doing this. I'm changing this, but I want to get to 0.2 volt here, so I'm gonna change step by step. I'm not getting close to 0.2, but so yeah, so pretty much 0.2 volt VS is giving me 0.2 voltage on the diode, which is still expected because we're still far away from the forward voltage. Let's keep increasing and see. To 0.3, I want to get to 0.3. Now the scale changed here from millivolt to volt. Okay, so 0.3 volt VS is giving me 0.3 volt on the diode or VD. Let's keep going. I want to get to 0.4 volt. Yeah, so 0.4 volt VS. So for each value of those, what's you seen, to get the ID, so for each value, so you're gonna get the value of here minus the value of here divided by 100 ohm to get the IR, which is the same as ID, right? This is the third column of the table, right? Let's keep going. Let's see. Get to 0.5. Okay. Yeah, so 0.5 give me that much of VD. I'm 1.6 now for VD. So we start seeing some current going through the diode here, right? Because 0.68 minus 0.6, so it's going to be 0.08 divided by 100, that will give me some current going. So the current start going through the diode here. So from here I want to increase by 0.1. So 0.71 voltage is giving me 0.61, because we said the increment when we get to 0.6 volt for the VD, we need to be 0.01. So next one will be 0.62, what we are looking for. Pretty much this is 0.62 and 0.63. So pretty much this is 0.63. And 6.4. So for each value again you need to calculate the ID, and I told you a couple of times how to do it. 0.65, 0.66, 0.67, 0.68, 0.6. So as you see, it's slowly increasing now. This is 0.6, or this is 0.7 volt. Pretty much this is the forward voltage for this kind of diode. So pretty much we won't see that big of difference here. So let's do some simple math. To get 12 milliampere across the diode here, which is be the same as current here. So how much the voltage should be here, or should be here to get 12 milliamp? So obviously the voltage across the resistor, it should be 1.2, right? Because 1.2 divided by 100 is going to give me 12 milliamp. So Vs minus Vd, it should be 1.2 volt, right? Vs minus Vd should be 1.2 volt, which is the Vr, in order to get 12 milliamp. Okay, so let's see what the difference here. So here's 1.42 minus, let's say, 0.7. So we're still away from there, so it's about like 0.7 volt, right? We need to get to this minus this to 1.2 volt. Okay, this for 7.702. As we said, the increment is 0.01 here, so we need to get, oh, this is the next increment you need to add. This is the next value. This is the following value you need to add to the table. But 1.89, 0.72, we are getting close to 1.2 different. But let's go a little bit closer. So yeah, so 1.92 minus 0.72, that will give us 1.2 volt, which is VR. 1.2 divided by 100, we will have 12 million. So this is the last value you need to include in your table. I'm going to stop recording here.